All right, class. Today we're going to look at inequality and set building notation. We use this a lot when representing domain and range. So basically what it is that kind of a little bit of recall. Domain has to do with your x values, and range has to do with your y values. All right, and what these notations do is describe the span of numbers a function may come across on the x and y axis. Okay, so it's a way of writing it that we understand what they are. Okay, so the reason I'm doing inequality and set builder together is because they are similar. All right, set builder and inequality. Okay, so for inequality notation, okay, kind of start, we read this from left to right. All right. And a couple of the notations we need to know is the open point. So if your point is hollow or empty, it is called open. And what that means is that that point, wherever it's on, is not included in the set. Can't write today. All right. So the inequalities we use is less than and greater than. When you have a circle that's been colored in, this is called closed. All right, which means it is included in the set. All right, so kind of like similar to our solid and dashed lines on our inequalities. All right, so if it's closed, then you have less than or equal to or greater than or equal to. All right, so inequality notation, read from left to right. So let's look at this number line. We'll assume these are x values because they're going horizontal. All right, so we're going to describe this interval here of numbers, okay? And the way I look at inequality is that I look at the arrow, this arrow here, as being all the x values. Okay, so I look at that as my x, and what I do is I'll write that first. Okay, now is that arrow going to the right of the starting point or to the left? Okay, are all these x's greater than or smaller than the 2 where it has an endpoint? So this arrow means it just keeps going to the right. So we know that it starts at 2. We know that it's open, so it's going to be one of these. So all my x values are bigger than the 2. So as I move to the right from 2, everyone's bigger, 0.1, 0.2, 0.3, all the way to infinity. So we're going to say x is greater than 2. Now, the same way of saying the same thing, you could put your number 2 and say 2 is less than all the x values to the right. Okay, so x is greater than 2. All the x's are greater than 2, and the other way is 2 is less than all the x's. Okay, so x greater than 2 or 2 less than x is saying the same thing. Okay, but like the way I do it, I like to focus on where my x values are. So I always start with my variable, my x. Okay, so let's look at this next one here. So here we have a line segment, which means it has 2 endpoints. Okay, one is closed and the other one is open. Okay, so between these 2 points are all the x values. Okay, so when I write this, my x value is in the middle. Okay, and this is what we call that I like to call a between interval. Okay, we'll see this again later when we start solving different equations. And they have kind of the same format. So you have the low number, which is less than x, less than the high number. Okay, and that's what's going to happen here. So the low number here is -3. Okay, it's the x values are all bigger than -3, so -3 is less than or equal to x because it's closed. And then the 5 on the right side, that's the high number, okay, is going to be greater than all the x values to the left of it. So greater than facing the 5. All right, so no bar underneath because that 5 is not included in the it's not included in this set. All right, next thing. We have a and a gap here. All right, so when this gap is we look at it as a split interval. All right, and you're going to have two inequalities. All right, so this is my, let me draw that better. This is my x, and the gap we call OR, and then we also have x's over here to the right of it. Now this one's colored in, but this is really open. All right, just for notes, I don't know why it's green, so it's open just for our purposes here. All right, so we have split intervals of x values. All right, so basically, again, from left to right, small to big. We're going to write this. The x values are less than or equal to -3, or to represent the gap, the x values are greater than 1. Okay, so you have all the x's from 1 over. No equal to bar because it's open. All right, so here's two other ways that say the same thing. So we have -3 greater than or equal to x, or 1 is less than x. Okay, or you can say x is less than or equal to -3, or 1 is less than x. So like all three of these ways say the same thing. Just make sure it's consistent. Okay. So getting into set builder, this is going to be very similar. Not sure what happened there. Okay, there we go. All right, so notice these are the same intervals as up top here. All right, and all that's going to change is what we're going to add a little bit more detail to our inequalities. So the inequalities are just the intervals, but they assume one thing, that you're using a real number system. So set builder is more information. It can declare different number sets, and you may recall some of this stuff from middle school or not, but I'm going to kind of like write them over here. All right, so let's go through like different number sets we can use. All right, so this vocabulary is going to be very important for set builder notation. All right, so big N, that is the natural numbers. All right, so an example of that is 1, 2, 3, and so on. All right, then we have big W. All right, these are whole numbers. All right, example of that is 1, 2, and 3, but we include 0. All right, then we have a Z. Okay, these are integers. All right, example of this would be -2, -1, 0, 1, 2, and so on. Okay, so negative numbers are included there. And then we have the rational numbers, which is denoted by capital Q. All right, so basically rationals are fractions. All right. Example of this are the numbers in between these integers. So we got -1, -0.5, 0, 0.5, 1, so forth. Okay, so all the numbers in between numbers. All right, and then we have the real numbers. Okay, so I'm going to star that, big O R. Okay, the real numbers are all the numbers that are not repeating, that are not definite decimals. In other words, you have a decimal, when you convert these things to decimals, they stop. Like 0.5 doesn't have a repeating decimal. Okay, these are repeating randomized decimals. So A couple of examples is, well, an example is pi, okay? So real numbers is basically all the numbers. All right, so example, like I said, is pi, okay? So it's 3.14 and keeps on going, all right? So there's all of those. So they include irrational numbers is what it is. All right, and then we have one more set that we may talk a little bit about, or we'll get into later, is the imaginary numbers. So the set builder notation is just like inequality, except you can declare different number systems. You can be very specific. All right, so those are our number systems, and we'll get more into imaginary numbers later in the year. So a couple of terms we have is this weird looking E. So kind of like start off like a C and then put a line through it. All right, this is called element of. All right, then we have a big old vertical line. This means such that. And then we have these braces, squigglies. That means set of. Okay, so here's the same number systems. Okay, this is open. All right, and basically what we're going to do is we're going to declare a number system and give the inequality. So we're going to start with the brackets here. Okay, and I'm going to say x, and we're going to check the x values. You can even say y values, whatever values we're using. So the set of x is an element of, so I'm going to put this element symbol, and then we can declare a number system. So let's say real numbers. Okay, so we know x is the variable, it's the real number, so we know what numbers are eligible, such that, and then we insert our inequality. X is greater than 2, then close the brackets. All right. Let's go on to the next interval. All right, so we can say the set of x is an element of the real numbers such that -3 is less than or equal to x is less than 5. Okay. And when we get into reasonable domain, we'll talk why we would want to declare different number systems. But for now, we'll use real numbers. Okay, so for this interval, set of x is an element of the real numbers such that x is less than or equal to -3 or x is greater than 1. Close the set. All right, so all it did was just include the inequality in there, declaring a number system, and using some math terms in there. Sometimes there's even a shorthand version of this. So let's say if this is missing, this is missing, what do? Well, you're going to assume that it's real numbers. Okay, so if the number system isn't declared, assume real numbers. So in this inequality thing here, since there was no number system declared on it, we're going to assume these are real numbers. We're going to include all the points within points in that number line. All right, so a lot of times they'll write a shorthand like this. So they'll say x is an element of, not x is an element. Let me try this again. Squiggly x such that x is greater than 2. All right, sometimes they'll write it like that. And when that part is missing, the real number part, you're assuming real numbers. Okay, so if it's not declared, assume real numbers. That's why it's starred. That's the one we're going to use the most. But these other number systems do have a place. All right, guys, so that is set builder notation. Have a good one.